I welcome you to the session on how mathematical models, mathematics, and algorithms are transforming global logistics and supply chain science. So, today we are living in the world typically called VUCA world, where the uncertainty both at the upstream side and downstream side are significant. We are concerned about bullwhip effect. We are concerned about the global changes in the tariffs and many other dynamically evolving situations. I am Professor Jitesh Thakkar, Dean Academics and Professor Logistics and Supply Chain Management at Gati Shakti Vishwavidyalaya, Central University, under the Ministry of Railways. On the right hand side, you can see the textbook I have published, co-authored with Professor S.G. Deshmukh, faculty at IIT Delhi. You will find a lot of interesting material, Mastering Logistics and SCM, 100 Insights. And this session also is based on some of the important ideas presented in this book. So my profile, you can appreciate I'm operating in the domain of logistics and supply chain management, operations management, Six Sigma, quality, project management, optimization, system dynamics. And my research is published in some of the leading journals, International Journal of Production Economics, International Journal of Operations and Production Management, Transportation Research Part E, International Journal of Production Research, Production Planning and Control, and so on. And I have published 5 textbooks: Structural Equation Modeling with Springer, Project Management with Springer, Multi-Criteria Decision Making with Springer, Mastering Logistics and Supply Chain Management with Gati Shakti Vishwavidyalaya Publisher, and Service Analytics and Management with Cambridge Publisher. You can scan the QR code on the left side, which is my YouTube channel named as Professor Dr. Jitesh Thakkar, and you can explore the intellectual content on this channel, which is benefiting students, faculty, and industry professionals. You can refer my research in the domain of logistics, supply chain management, quality, Six Sigma by scanning my Google Scholar QR code. Connect with me on LinkedIn, scanning the QR code available on left corner. Gati Shakti Vishwavidyalaya is Central University with a vision to contribute in transportation and logistics sector in all 3 dimensions: technology, infrastructure, management, policy, regulation. And university has entered into the MOUs and collaborations both at national and international level to support the vision of the university, innovation-led, industry-driven university, and mandate of the nation to reduce the logistics cost from present 14% to 8 to 9%. University offers academic programs for both regular students and working professionals. The programs are at the BTech level with a focus on rail engineering, transport engineering, MBA logistics and supply chain management, and for working professional, there are MTech in intelligent transport system, MTech in railway engineering, MTech in bridge and tunnel engineering, and MBA in logistics, supply chain management, metro rail management, multimodal transportation, aviation operations management, and so on. You can check the details of the program, the detailed curriculum at the given link, and this will help you to appreciate the contribution of the university and focus of the university in the niche domain, transportation and logistics sector. When we talk about the supply chain science, it's all about data-driven analysis, scientific analysis, integrating mathematical model, optimization techniques, artificial intelligence, machine learning based approaches, and the fundamental principles of economics. And typically, it intends to reduce the wastages, inventory, aims to offer stochastic modeling, data analytics, and machine learning approaches with 4 important objectives. One is the cost reduction across supply chain. Number 2 is the improved service level. Number three is enhance resilience. Typically, a lot of disruptions are happening globally. And number four is the competitive advantage, how you can compete in terms of flexibility, responsiveness, cost, and quality with respect to your competitors. So, when you talk about the mathematical model, it is a representation of some real life problem. It is to match the observation with the symbol like representations, informs theory and explanation. A mathematical model is central to most computational scientific research. There are various other terms used when you talk about the mathematical modeling. It's a computer modeling, computer simulation, computational mathematics, scientific computation, and so on. The success of mathematical model depends on how easily it can be used and how accurately it predicts and how well it explains the phenomena being studied. It should not go far from the reality. It should accommodate the realistic constraint and offer the practical, feasible solution for the problem under investigation. When you talk about mathematical modeling, then the key steps involve identifying the problem area, conduct background research, state your project goal, define relationships, develop mathematical model, then you develop the computational algorithm, perform test calculations. Subsequently, you interpret the results and communicate your recommendations to the management. Let us get deeper into the complexity and stakes of modern supply chain and why algorithms, the optimization approaches have become almost inevitable, and we cannot really optimize our supply chain based on traditional practices, repeating the same practices, or based on the naive approach or intuitive approach. So today's supply chains represent some of the most complex systems in the global economy, with millions of interdependent decisions being made every second across continents, companies, and commodities. So your supply chain is spread across globe. And today, when we talk about dynamic tariff and the various changes taking place in the global supply chain, every minute your inventory related decisions, your dispatch related decisions, loading, unloading of the cargo, your market distribution, diversification, all decisions, they keep changing. If you look at some of the interesting statistics, then the supply chain today, high stakes, why data driven approach is required. $4.3 trillion, that is e-commerce sales, projected global online sales by 2025, and diving unprecedented demand for speed and precision. If you look at the daily data, 400 TB data supply chains are handling, and supply chain data generated daily from IoT sensors, ERP systems, and supplier networks, it's huge. And if we cannot reveal the pattern, uncover the pattern, and discover some of the important elements for supply chain optimization decision making, we are almost losing our business. 60% impact range. So, of industries affected by semiconductor shortages, showing how disruptions ripple globally. And if we don't make the sound data driven decision, then this impact goes as high as 60%. If we go further to appreciate why algorithms matter from reacting to proactive supply chain approach, then it is AI powered predictive maintenance management, predictions, accuracy desired in the forecasting. So traditional method typically with such a huge data set and vulnerability in the business environment fails. So manual forecasting and fixed routes collapses under the modern complexity and market volatility. Algorithms offer unique advantage. It's a real-time decision-making, predictive insights, and autonomous operations at scale. Measurable results: 15 to 30% cost reduction, 40% lower risk exposure, and 25% improvement in customer satisfaction has been realized when companies they have opted for the advanced algorithm based data analysis and optimized data driven supply chain management decisions. Let us look at the core algorithm families in supply chain science and what are the different algorithms, approaches that are helping today's manager in making the sound decisions in supply chain optimization. So, number one is optimization algorithms like linear programming for resource allocation, maybe manpower allocation, allocating the cargoes or allocating the warehouses, mixed integer programming for facility location. It is the variant of linear programming, genetic algorithm for complex constraint. So typically you are not very much concerned about the exact optimization. You are here more concerned about accommodating the real life constraints and reaching closer to the optimal solution. So you will go for evolutionary algorithms. Simulated annealing for non-linear problems, combinatorial problem, traveling salesperson. You can use the exact optimization approaches like mixed integer programming or integer programming, branch and bound, but many times the combinatorial problem with the real life constraints becomes extremely difficult to solve with the traditional approaches, and evolutionary algorithm provides much amicable way where you are closer to the optimal solution and providing the most realistic solution to the real world problem. So let's look at the real-time application. DHL's AI-driven route optimization adjusts to traffic and weather conditions, reducing delivery times by 15% and fuel cost by 10% while balancing driver workloads. So multiple advantages it offers, and typically it reduces the delivery lead time, cost, fuel cost, and balances the driver workload. Number two is predictive analytics and forecasting algorithms. So here you have the variety which includes time series models, ARIMA, exponential smoothing, Prophet models, direct seasonal pattern in historical data, which detects the direct historical patterns in the historical data, and machine learning. So gradient boosting and neural network incorporates external variables like weather and promotions. Bayesian models widely used, extensively used, where you can quantify the uncertainty in forecasting that helps the planner prepare for multiple scenarios. If you look at the real world impact, then Amazon's demand forecasting algorithms improve inventory accuracy by up to 30%. It's a huge. So you just see large scale of inventory Amazon is managing and lakhs of orders every day Amazon is handling. And if they can improve their inventory accuracy by 30%, it can really add to the great competitiveness of the logistics and supply chain. So typically they improve the inventory accuracy by 30% and simultaneously reduces the stockouts, overstock situation by analyzing billions of data patterns. There are huge orders, returns, and they really have to tap considering the consumer preferences, the quality of the product, the geographical diversity and preferences. Lot many factors are there, and this is something where Amazon is really getting benefited with the AI-driven Bayesian models, and this improves the logistics competitiveness of the Amazon. Reinforcement learning algorithms. So this is the third category where the real-time data-driven supply chain science decisions are possible. So reinforcement learning typically represents a breakthrough approach that learns optimal policies through trial and error. So it learns through the data trial and error in dynamic environment and perfect or constantly changing supply chains. So a couple of algorithms which are widely used by the leading corporates: Q learning for discrete action spaces, deep Q networks, typically called DQN for complex state spaces, policy gradient methods for continuous control, multi-agent, reinforced learning, coordinated decisions. So if you look at the real-time application, then adaptive inventory management system at Unilever use RL, reinforced learning algorithm, to dynamically adjust reorder points, reducing inventory cost by 18% while maintaining 99.5% service level across volatile products. So you can see Unilever and many companies in the FMCG segment, they are dealing with huge variety of product portfolio, and the demand fluctuations are significant across product sector, and really they need to learn from the data very fast and adjust their inventory to the market expectations, market requirement, or the consumer demand. The fourth is machine learning classification and clustering. This is something where very well-known approaches used are K-means clustering. So groups suppliers by performance metrics to develop segment-specific strategies. So you have the suppliers, you can segment them depending upon the lead time, customer complaint, lead time, and you can categorize them for the segment. And this can help you to develop better vendor management strategies. Decision trees, let us say it classifies products by supply risk, lead time, and value for tailored inventory policy. So if you look at the aviation sector, then the lead time are significant when you are dealing with the MRO, you are purchasing the components from the other country, and typically decision tree approach can help you to minimize your risk at the supply end and make the informed decision about your procurement lead time. The random forest, it combines multiple predictors to identify high-risk suppliers with 85% accuracy, as many of the organizations they have experienced. If you look at the real-time application, then Toyota uses ML classification, machine learning classification, to categorize 10,000 plus suppliers daily. So automotive giant is dealing with more than 10,000 suppliers, and absolutely it is important to classify them depending upon quality, lead time, and various other parameters. So daily by risk level, prioritizing the audits, how frequently you will audit the supplier, or you will invest into vendor relationship management and interventions to prevent disruptions before they occur. Let us go further in our discussion, and the fifth area of mathematical modeling and algorithm for supply chain science is natural language processing, NLP algorithms. So key capabilities are named entity recognition, extracts key term from the contracts. So you are signing the various contracts with the supply chain partners. It may be the buyback contract or return policy, whatever. So you are getting into hundreds of contracts, and the credibility of your relationship and business is absolutely decided by the contract. And typically, natural language processing helps you to identify the key elements terms from the supply chain contracts. And based on that, you can improvise your contract or take the informed decisions. Sentiment analysis, which is again part of NLP, gauges markets and supplier signals. So you can do the text analysis, sentiment analysis, and very well capture that how consumers are behaving or what they are expecting when it comes to the sales or positioning of the product. Transformer models comprehend complex procurement language. Number 4 is document classification, sorts, and root supplier communications. All these are part of NLP algorithms, and it extensively helps the supply chain managers to get into the highly critical dimensions of either formulating the contract or evaluating the suppliers or catching some advanced information about consumer behavior and market trends. So NLP algorithm reduce contract review and time by 80% while improving compliance verification by 35%. We can look at the real-time application. Procurement team at GlaxoSmithKline use NLP, natural language processing algorithm, to automatically analyze thousands of suppliers' contracts, accelerating procurement cycles while ensuring regulatory compliances across global operations. Let us go deeper and appreciate a couple of applications across supply chain functions. So when you look at the area demand forecasting and inventory optimization, AI-powered forecasting is one of the most popularly used approach. Neural networks with appropriate weightage setting analyzes the select sales trends, seasonality, promotions, and external factors like weather for precise demand predictions. You can look at the second domain, which is multi-echelon optimization. So here you are dealing with the stochastic programming, which balances inventory across distribution networks, which minimizes the total cost while maintaining service levels. Number three, dynamic safety stock. So in today's environment, you cannot just live with one reorder point or the safety stock for a longer period of time. And you really have to adjust your safety stock dynamically. So adaptive algorithms adjust buffer inventory based on forecast confidence intervals and supply reliability metrics. So at one side, you are defining the confidence intervals. Statistically, 95% confidence interval, 99%. It means whether I would be able to meet my demand 99% times or not. And on the other hand, you are considering the reliability matrices. Typically, what is the uncertainty level at the lead time, procurement lead time at the supplier end. So if you look at the example, then Walmart's advanced machine learning forecasting system analyzes 500 plus variables to reduce inventory cost by $1.2 billion annually while maintaining 98% product availability across 4,700 plus stores. You just look at the scale of the business and the supply chain complexity involved in Walmart, and absolutely without ML forecasting system, they cannot manage so many variables and the product availability across more than 4,000 stores. The another important area where you extensively need the advanced optimization algorithms is logistics and route planning. So the prime objectives when it comes to route planning are fuel reduction, driver hours, vehicle maintenance, reduced penalties, and administrative cost. And certainly, this is very much linked with the environmental carbon footprint. So UPS Orion algorithm saving sources you can refer, and this 5 typical advantages are cited. So key algorithm approaches, one is dynamic vehicle routing problem, DVRP, which reroute deliveries based on real-time conditions. Combinatorial optimization balances load efficiency with time constraints. Multimodal transport algorithm optimizes across trucks, rails, ships, and aircraft. Last mile delivery optimization for autonomous vehicles and drones. So here you can use the neural networks, evolutionary algorithms, typically to accommodate the real life constraint and handle the complexity involved in the large scale problem. Just look at the example. UPS saved $50 million annually by implementing their Orion algorithm, which optimizes delivery routes for 55,000 drivers daily, reducing each route by an average of 7.6 miles. So I hope this would help you to appreciate the importance of mathematical models and algorithms as a part of supply chain science. Warehouse automation and quality control is another very important area where the mathematical models and optimization algorithms have shown miracle improvements. So computer vision algorithms, one of the domain is so convolutional neural networks automate product sorting, picking, and defect detection with 99.8% accuracy. On the other end, you can look at the robotic process automation. So path planning algorithm guide autonomous mobile robots, typically called as AMRs, through dynamic warehouse environments. Bin packing algorithms, 3D optimization determines optimal product placement for storage density and retrieval efficiency. If we just look at the example, then Okado's AI-driven warehouses achieve 50% faster order fulfillment with 99.9% picking accuracy using a coordinated swarm of 3,000 plus robots. Let us look at another important area where the optimization algorithms, mathematical models as a part of supply chain science are extremely useful is the supplier selection and risk management. So multi-criteria decision algorithm, typically analytic hierarchy process, TOPSIS, which evaluates suppliers across cost, reliability, quality, sustainability metrics, lot of conflicting criteria. Predictive risk modeling, ensemble ML machine learning models flag supplier risk by analyzing financial data, new feeds, and geopolitical signals with 87% predictive accuracy. Network analysis, graph algorithms identify critical suppliers and bottleneck with multi-tier networks to prioritize risk mitigation efforts. You can look at the case study. Boss implemented AI-powered supplier selection algorithm to source components competitively while reducing supply chain disruption by 40% during volatile market conditions. So, by various examples and addressing the issues both at the upstream side of the supply chain, downstream side of the supply chain, we have appreciated extensively the use of mathematical models, the modern and advanced AI and ML based algorithms for optimizing supply chain decisions. So, key algorithm components include stream processing engines analyze millions of events per second. Complex event processing detects pattern across streams. Anomaly detection flags deviation from expected performances. And perspective analytics recommend optimal corrective actions. So if we look at the real life application, then Rombi's AI platform integrates IoT sensor data with logistics information to provide predictive alerts and compliance verification across 190 countries, reducing shipment delay by 60%. Let us see the cutting edge algorithms which are shaping the future. So, reinforcement learning for adaptive supply chain, which is one of the most cited approach. So, emerging research frontiers include multiple agent reinforcement learning, RL synchronization for production, inventory, and delivery decisions dynamically. Hierarchical RL handles long-term strategy and short-term tactics simultaneously. Transfer learning adapts models across product lines and geographies. Digital twin simulates provide safe training environments. So parallelly, you can mimic the scenario and understand. And if any change are desired, you can apply those changes in the generated scenario which is highly complex. Lot of non-linear relationships are involved, and before you actually go for the real life implementation, you can understand the risk involved and you can find out the optimal strategies to deal with the uncertainties. Industry challenge: scaling from controlled test environments to real world complexity while maintaining algorithmic stability is one of the challenge when you are dealing with all these modern and advanced prediction based algorithms for supply chain optimization. So potential to minimize the bullwhip effect and ripple effects in volatile market by up to 65% compared to traditional methods. Gen AI, typically called generative AI and explainable AI in supply chain, is one of the recent and latest advancement extensively used. So there are a lot of Gen AI applications like scenario generation for stress testing supply chain network under different kind of risk and resilience condition. You can test your supply chain network if there is a change in tariff or there is maybe the disruption at the supplier end or the distribution network has failed or natural calamity. You can do the stress testing for your supply chain network. Synthetic data creation for algorithm training, natural language interfaces for supply chain queries, and automated report generation from the complex data. So these are a variety of applications and utility of Gen AI in the supply chain optimization. Explainable AI, it has a lot of importance in optimizing your supply chain and making your supply chain more resilient. Line and SHAP, LIME and SHAP methods explain black box model decision. So there are a lot of causality within the black box. Your supply chain decisions are triggered based on many phenomena. And this is something where explainable AI, considering the complex relationships, causal relationships, can help you to understand this situation. Build trust within human planners and the stakeholders. You have multiple stakeholders in your supply chain, both internal and external. Ensures regulatory compliance and ethical decisions and enables effective human AI collaboration. So, industry forecast, if we look at some statistics, then Gartner predicts 25% of supply chain KPI reporting will be powered by Gen AI by 2028, creating a competitive advantage for early adopters. So, broadly, we can conclude, having gone through the variety of applications of mathematical models and AI tools, modern optimization approaches, mathematics and algorithms are no longer optional. So let us accept the fact that today, without technology, you cannot run your supply chain, plan supply chain decisions, optimize your resources within the supply chain. They are the backbone of resilient, efficient supply chains. Businesses embracing these technologies gain 30 to 40% more agility, 15 to 20% or 25% cost savings, and significant competitive advantage. The future, fully autonomous, self-optimizing supply chains powered by AI and advanced algorithms cannot be ignored. An early entrant in this technology, early adopters of this technology will certainly gain a greater competitive advantage through their supply chain in the market. So, call to action: invest in algorithmic innovation today to lead the supply chains of tomorrow. So, with this, we have appreciated the role of supply chain in understanding the key enabling technology and how it can optimize the supply chain decisions. So, Gati Shakti Vishwavidyalaya is India's first and only university in transportation and logistics sector with a very clear mandate to enhance the ecosystem of transportation and logistics sector in India and reduce the logistics cost from 14% to 8 to 9% by having innovations, industry-driven approach in all three domains: technology, that is infrastructure, management, that is services, and policy, that is regulation. Thank you very much for your interest in understanding the use of mathematical models and algorithms in optimizing supply chain decisions and the variety of applications presented in this video, the different areas where supply chain optimization is required across the supply chain, and the variety of tools and techniques or mathematical models and optimizations explained would certainly help you to appreciate the criticality and early adoption of these tools and technologies for enhancing the competitiveness of your supply chain.